Set them equal. They're both solved for x. So your equation is going to have y's in it. Y minus 2 squared equals y. And you'll FOIL this out, so you'll get y squared minus 4y plus 4. Get all your terms on one side, subtract a y. Y squared minus 5y plus 4. And how do I factor that? Y minus 4, y minus 1, minus 1. So I get two solutions. I get y equals 4 and y equals 1. To turn these into our actual points, you plug them into either equation, doesn't matter. Let's use y equals x, and you'll get the points 4, 4, and 1, 1. Okay. Are we all okay with that part? Yeah. Let's plot those points. Yep. Okay. So let's plot 1, 1, 2, 3, 4. What kind of equations do I have? Let's look at y equals x. What kind of equation is that? A line. It's linear. I've got 2 points. I can make a line out of that. Hopefully my drawing skills don't fail me. Here's my line. Okay. Now let's go back up and look at our equation here. There's a square, which tells me it's a parabola, but notice the square is on the y, not the x, which means instead of opening up and down, it's going to open left or right. So I know, and the coefficient of y squared, it's going to be positive 1, so it should open to the right. I just need one more point. I already know kind of what the picture looks like. But 2 points is really not enough to graph a parabola. So let's take our equation here. It was x equals, no, I'll do it underneath here. X equals y minus 2 squared. And I need one more point. Normally, you plug in a value for x and it outputs a value for y. But here, really what you've got is x is really a function of y. I'm going to plug in a value for y, and it's going to output a value for x. And I want it to be between my intersection values. Y was 1 and 4, so pick a y value between those. So let's say 2. If you plug in y equals 2, you're going to get x equals 0. So I get the point 0, 2. Okay. Get the point 0, 2. So let's plot that on our graph. Go back up. 0, 2. So I've got 3 points now. And I know that the mouth opens to the right. So I can now draw this region. It's going to look like this right here. Okay. Are we okay with the graph now? Yeah. All right. I'm rotating about what line? Negative y equals negative 1. So that's this line right here. Okay, so I'm going to use cylindrical shells. My strips need to be parallel to this line. So they should be horizontal. So there's my strip. I'm going to rotate around and get my cylindrical shell. All we need to do now is figure out what R and H are. Okay, so let's do that. Maybe first, I like to always say what variable I'm going to integrate with. Which variable are we going to use here? Y. We're going to integrate. I'm going to abbreviate with respect to Y. That should be your variable. Because your strips are horizontal, there's a left and a right function. That means Y. All right, let's start with our radius. We have two things we need to find, radius and height. Maybe we'll start with height. Okay, look at my strips. I want the height of this strip, okay? So I have a right and a left function. Remember, it's right minus left. So I'm going to use the line as my right function. The line was represented by y equals x, or alternatively x equals y. So my right function, it's going to be y minus, and then my left function was the parabola, and it was represented by y minus 2 squared. So that's my height. Let's come down there. Y minus 2 squared. Okay, again, that's just right minus left function. Now the radius. The radius is always the part that's going to change when you're not rotating about an axis line, because your strip has now changed its location. The height doesn't change of your strip depending upon where you're rotating about. It's only your radius that really changes. So let's look at our picture and figure out our radius. Bless you. So radius, remember, it's from my rotation line all the way to my strip. So it looks like, bless you, your radius should be that distance right there, the blue distance. So view this in pieces. I have this distance right here is always 1. From -1 to 0, that's always 1. And then this extra distance right here that I'm missing, that's a vertical. Maybe I'll use green for that. It's a vertical distance. So that's represented by y. And remember, I'm integrating with respect to y, so that y, I don't need to change it. It can stay y. Bless you. So how do I get the blue line? You add up the red and the green. Okay, these add up together. So we're getting 1 plus y for that. Did I get that? Yeah. Okay, so we now know R. We know R and we know H. Those are the two pieces of information you need to know, and then you can set up your integral here. Okay. So let's set up our integral. So, Let's look at our picture. I said R. Let me zoom in a little bit on this picture here. R is this blue line. It's from my rotation line to my strip. So I want to calculate that blue line. So what I do is I break up that blue line into two pieces. I know the distance from the x-axis to my rotation line, it's 1. That's this red. And then this green, it's the distance from my x-axis up to my strip, that's y. Okay? So to get this blue distance, I add these two together. Okay? You got it? We were subtracting, yeah. It all depends upon where your rotation line is in terms of your strips.
So if the rotation line was just on the x-axis, it would just be y.
Y, okay. Yeah. And if this, instead of doing y equals -1, if we did like y equaled, how high does this go? If we did y equals 5, this wouldn't be a plus anymore, there would be a subtraction. It would be 5 minus y. So it depends on which side of your strip your rotation line is, if it's above or below. Okay. Let's see if I can fix that. Okay. So let's compute our volume here. Our volume is going to be, not blue, 2 pi, the integral. So I'm integrating in terms of y. So it's r 1 plus y times h, y minus 2 squared. What bounds do I put on this guy? 1 and 4. What y goes between 1 and 4. Okay. So you're going to FOIL this second term out here, this y minus 2 squared, and combine it with that y. One plus y. So it looks like I'm getting minus y squared plus 5y minus 4. And then unfortunately we're going to have to multiply all this out, this 1 plus y times this minus y squared plus 5y minus 4. So you're going to have to distribute and then combine your like terms. Once you do that, you should get minus y cubed plus 4y squared plus y minus 4. So I'm skipping over the multiplying. I'm hoping you can do that on your own. And then you just integrate this polynomial. Minus y to the 4th over 4 plus 4y cubed over 3 plus y squared over 2 minus 4y. You plug top number minus bottom number. In this case, yeah, it's going to be 2 pi minus 4 to the 4th over 4, 4 times 4 cubed over 3, plus 4 squared over 2 minus 4 times 4, minus 2 pi, and then plug in 1 into that, negative 1/4, plus 4/3, plus 1/2, minus 4. So on an exam, that would be good enough for me. You could stop here. I don't really care necessarily that you can simplify a bunch of fractions together. But if you wanted to know what you get when you simplify this, you should get, what did I get? 63 pi over 2. Okay.
Can you write down the formula for cylindrical shells?
Mm-hmm. So it's to compute volume, what we're doing is we're doing circumference times height times thickness. So you're doing 2 pi r h, and then it'll either be dx or dy depending upon what you're doing. So if you were integrating in terms of x, it would be like that. 2 pi r h dx. Okay. If you were integrating with respect to y, it would be dy. Okay. One thing I want to mention, I want us to look back at our region again. Here, so let me draw it again because I want to bring up something important here. Note. So let me redraw it. This is going to be a rough sketch of our region. You can look up above on your notes for the. Okay, so I had the line, and then this guy, like that, and my rotation line was negative y equals -1. We have two methods for finding volume. We just did it with cylindrical shells, but what if I went with the method we used in the previous section, washers and discs? So if I do a washer and a disc method, my strips, remember they're perpendicular to my rotation line, so now my strips are going to be up and down. I rotate this around. Am I going to get a washer or a disc? A washer, because there's space between my strip and my rotation, my strip here. So when I rotate it around, we're going to get a washer. And we have top and bottom, so we're going to integrate with respect to x. I want you to think about the strip though. As I move it, remember I said top and bottom. So over here, the way I've drawn it, the top is the parabola, the bottom is the line. But as I move it to the left, the bottom function changes. It becomes parabola, parabola, right? If I draw my strip over here, the bottom function is different. So what that means is if you wanted to use this method, you're going to have to compute two separate integrals, okay? So if we use the washer method, we would need two separate integrals. You would have an integral between 0 and x's between 0 and 1, and then you would have a different integral between 1 and 4 for x. And I don't want to compute two integrals, right? It's better to compute one and save yourself a little bit of work. So sometimes for your setup and your problem, one way will save you a lot more time and energy and effort if you do it with one method over the other.